We have two different options when we're finding a slope at a point. Tangent slope. And there's no particular order to this. I'm going to use the h notation instead of the delta x. One is take the limit as h approaches 0 of f of x plus h. I had a delta x there earlier, minus f of x divided by h. So h and delta x are the same thing. So that's one approach. The other approach, and let's see, I lied slightly here. We're looking at a particular point, so often that x value is called a instead. All right, so graphically, we have some x value here, we're calling it a. We jump over to the right by a little amount h, that gives us a new x value called x plus a plus h. And then that's related to these 2 points, f of a, where the y values are f of a and f of a plus h. And so we're trying to find the slope of that line. And we have some curvy thing going through there. Maybe it looks like that this time. And what we want to do is we want that h to go to 0. Let h go to 0 there. The other way to think about it is instead of calling this a plus h, we could say, that's too many letters. Let's call that just that value b instead. So another way to approach this is the limit as b approaches a of f of b minus f of a over b minus a. So that's another way to write it there. So we could do it either way. And sometimes I like the green version, sometimes I like the red version. It kind of depends on the problem. So let's look at a more complicated problem. Let's take f of x equals 3x squared minus 6x plus 5 as our function, and we're going to let a equal 2 this time. And let's use the first method here that we used earlier. Here we're just throwing an h in instead of a delta x. So that means we need to find what is the limit as h goes to 0 of that f of 2 plus h minus f of 2 all over h. So I'm going to do the algebra, and I mentioned I use a 4-step process for this. First thing I do is I figure out, well, what is that right there? And then what's the difference? What happens algebraically after I divide by h? And then finally, we try to look to see what happens as h goes to 0. And sometimes it's pretty straightforward. Sometimes it is totally not. And so over the next couple of days, next few days, we're going to work through those harder cases. So new page. I'm going to rewrite the function as f of blank equals 3 blank parentheses squared minus 6 blank parentheses plus 5. And so if you have a hard time with some of these with the a plus h, this is one way that might make your life easier. Then in here, we're going to just put a 2 plus h everywhere we see there was an x, there's now a parentheses. That parentheses has to contain a 2 plus h. So that's the safest way to go about it. And then you're going to do all that algebra. So I'm going to pause for a second while you start doing that algebra, and then I'll catch up to you. so unless I made a mistake and you guys want to check my algebra on this, I get 3h squared plus 6h plus 5. Can anyone confirm that result? Evan got the same answer. Awesome, thank you, Evan. Okay, so either Evan and I have the same bad algebra or we have the same good algebra. So let's make believe it's good algebra. So second step is we subtract f of 2. So what is f of 2 here? So step 2, from that result, f of 2 plus h, we want to take away f of 2. So let's just see what is f of 2. So f of 2 is 3 times 2 squared minus 6 times 2 plus 5. Let's see, 3 times 2 squared is what? 12 minus 12 plus 5. It looks like it's just 5. So now I have that this right here is the 3h squared plus 6h plus 5, and then we're going to minus a 5. So the first part, 3h squared plus 6, oops, that's not a very good 6. Right, so that's this. Now we're subtracting f of 2, which is just 5, so that's convenient. So now I get 3h squared plus 6h plus, no, plus 5. What's that? So that's the numerator. So step 3 is to divide this result by h. So what is, and you don't really have to keep rewriting this stuff here. Just kind of think about it as step 1, 2, 3. So if I take that 3h squared plus 6h and divide the h out, it looks like I just get 3h plus 6. And then the fourth and final step is to take the limit of that right there. So I want the limit as h goes to 0 of that difference quotient. Right. So, and you don't really have to rewrite that there. We wrote it earlier. What is the limit as h goes to 0? But you should write this part of 3h plus 6. Well, this term right here is getting smaller and smaller and smaller till it essentially disappears, leaving just the 6. So we should see that the slope of the tangent line there is 6. So we should verify that this is true, and we can do that in a table of numbers, or we can do that on a graph. So we think if we start with f of x equals 3x squared minus 6x plus 5, that the slope of the tangent line when x equals 2 is 6. This guy right here has the point we just calculated, 2, 5. So that means the actual line should be y minus 5 equals 6 times 2, oops, x minus 2. All right, so that's that point slope formula. Plug in the y value, plug in the x value, plug in the slope. So that should be the tangent line. So easiest thing to do if you don't already have a spreadsheet set up to try and do it is to look at the graph. So let's look at the graph. And let's make a new GeoGebra graph. Start over. All right, so my f of x equals 3x squared minus 6x plus 5. Okay, and I am interested in the points 2 comma f of 2. Which computer says, yep, that's 2, 5. Okay, so here's my point there on the graph. And then let's drop the tangent line and see if it looks okay. If the tangent line is askew through that point or misses the point, then something went wrong. So y minus 5 equals 6 times x minus 2. And ooh, that looks pretty nice. All right, so let us play around zooming in there a little bit. So I mentioned before, one reason I like GeoGebra is if I go to the tools here and I click move graphics, I can rescale an axis. And then I can kind of zoom in there. And yeah, that looks like a pretty good tangent line. What do you think? I think we did all right. And again, we could double check by using maybe a spreadsheet or a calculator to calculate some values near there to see how we did. So this line right here mimics the slope of the curve. If we're standing at that point, if we step any tiny bit to the right for X or to the left, we're going to find that we're steeper or shallower than at that point on the curve. And that's what this thing we're doing. So let's summarize and try a new example. What we're doing right here is finding what's called the derivative of a function at the point. Okay, so this 6 right here is sometimes referred to as the derivative of f of x at x equals 6. And what is it we're deriving right here? Well, what we're deriving here is the rate of change of the function, right? So derivative. We're deriving the rate of change. Deriving rate of change at 6. And when people first started doing this kind of math a long time ago, they realized that it's technically not a rate of change anymore because we don't have 2 points. We're just looking at a single point, right? And not at x equals 6, at x equals 2, we get 6. Change at, and I messed that up over here too, at x equals 2. So the rate of change seems to be 6. And they started using the word derivative instead because, again, it technically isn't a rate of change because we don't have 2 points. Change means you have to have 2 instants in time, which is kind of weird. But time is kind of weird anyway. So questions on this example and what we're working on here?